All right, here's the problem. They give us a binary tree and they ask us to find the diameter. And they define the diameter as the maximum length from one node to another. So in this case, our length would be, 4, 2, 1, 3, which would be 1, 2, 3. Or it could be 5, 2, 1, 3, which is 1, 2, 3. But they do give us a hint. They say that this path may or may not pass through the root. So let's see a case where this happens. So we have our happy case here, where it's 1, maybe something like this, and our diameter indeed passes through the root. We have 1, 2, 3, 4, for a diameter of 4. But let's see another tree where this isn't the case. So we have maybe something like this, super heavy on the left side of the root, and then really light on the right side. So in this case, our diameter is actually 1, 2, 3, 4, 5, 6. And if we try to find the diameter of the root, we would have gone something like 1, 2, 3, 4, 5, and return 5, which is incorrect. So what this hint tells us is that we want to find the diameter of each node and keep track of the maximum that we've seen so far. We can't just assume that the root's diameter will always be the correct answer. So to do that, we will just simply keep track of some sort of a max diameter that we've seen so far. Okay, so now the question becomes, how do I figure out the diameter? And what we can do is we can define diameter as the length of the left side plus the length of the right side. And remember, each node is trying to figure out what its diameter is. So let's give a little simulation here. So we come in through the root and we ask, okay, what's the diameter of the root? And he says, well, I need to know the length of my left side. So we go down to the left side and he says, what's the diameter? And he goes, wait, I need to figure out my own diameter first. So let me ask my left side. And here, same thing. I need to figure out my own diameter first. Let me ask my left. And my left is nothing. So my length of the left is just 0. And my right is also nothing. So now we know that this diameter is 0 plus 0, which is 0. And that's the maximum diameter we've seen so far. Now he's happy with what his diameter is, so he can finally answer the caller, okay, well, my length is actually 1. And this length here we get it from taking the maximum of either the left or the right, and then just plus 1 to get that edge back to the caller. So now this guy has his left side, but he wants to know his right side. So we do the same thing. You go down right, and he goes, wait, I need to ask my left. And then here, we get 0 and 0. So we also still have 0 for the diameter. And then we have 1 back here. And then 1 here, he asks his other side, which will be 0. So now, the diameter of this node will be 1 plus 0, which is 1. So we've seen a bigger diameter now. And he's happy, he returns, and he says, okay, my length is 2. And you can see that the length here is indeed 1, 2. Okay, so now he has left and right. We do the diameter calculation. So now the diameter is 3. That's the biggest we've seen so far, so we'll keep track of that. And then here, to return up to what's the length of my left side, we're going to take the longest length that we have here, which is 2, and we're going to add 1 to it. So this is going to be 3. So the length of this left side is now 3. And you can see that it's 1, 2, 3. Okay, so now the root will ask, what's the length of my right side? And my right side, we're going to go through the same thing, 0, 0, 1. So now we have 3 and we have 1. So that means our maximum diameter now is 4. And then as we exit, we don't really care what the length of our root node is. We just care that now we have a maximum diameter of 4. So how would this play with our example of a super heavy one-sided where the root doesn't have the maximum? Well, we're going to get our maximum diameter of 6 here. And then as we return up, our length here is 4. Our length here is 1. So we'll return, 5 as a diameter. But since 5 is less than 6, it won't overwrite max. So our answer will still be correct with 6. Okay. So we can see from here, we kind of have a general structure for how we want to code now. We want to figure out the left side, figure out the right side, and then, possibly overwrite maximum if we need to, and then we'll return our own length, which will be the maximum of, the length of the left, the length of the right, plus 1 to get that edge back to the caller. And it's going to be a recursive solution. So this length will call itself, this length is calling itself. So let's see how coding this out will look like. Okay. So here what we want is we want some way to get the length of a tree node. We'll call this node. But we also want to make sure that we're keeping track of our maximum diameter. So here what you can do is either you can do a private int max diameter, so you store it as a private variable in the class solution, or if you want to be a little bit cheeky and not have to use the class solution, you can actually store it as an integer array of max. An integer array just helps to make sure that when we update the value of max within our recursion, everybody will see this new updated value of max. So now we can do something like this, where we have an int array of just size 1, and we start out with 0, so our maximum diameter is 0. We call getLength of our root with our max, and then we return our max at 0, which will be the diameter. And then here we'll do a quick safety check. If root equals null, return 0. And that way in here we can assume that node does not equal to null. Okay, so in here our first idea is let's ask what the length is. But only if the left side exists, right? So if node.left does not equal null, then we can get the length of our left side. Otherwise it's 0. So if you haven't seen the ternary operator before, this is pretty much equivalent to int left equals 0. If node.left does not equal null, then left is equal to get length node.left max. So this is pretty much equivalent, and this just gives a one line for it. So we'll do the right side as well of our node.right. But if our right side doesn't exist, meaning that it's null, we'll just have 0. Now we have our diameter, which will just be left plus right. Okay, and now we want to check if our diameter is bigger than max that we've seen so far. So if diameter is bigger than the maximum diameter we've seen so far, then max 0 is equal to diameter. And this is where using the array really helps, because if this was just an integer and we set max equal to diameter here, we've only affected the value of max within this function, and outside of this recursion, when we're going up the stack, nobody else will know that we've seen a maximum. So we want to make this an array of one element. Okay, so here now we can be nice and return our own length. So our own length will be whatever is the maximum of the left and the right side plus 1. So remember, we're choosing the longest path. It's either the left or the right path. And then we add 1 for the edge that connects back to the caller. Okay, so I think that's the end. If there's no errors, it should be good to go. Nice, so it's accepted. And that's the end of this challenge, and I'll see you on the next one.